Good morning, everybody. In today's lesson, we're going to talk about graphing inverses. We're going to graph inverses using the idea of a table as well as equations, and then we're going to show them on a graph. So let's get started. All right. If you're given a table, an inverse relationship is a flip-flop of x and y. So let me show you what that looks like. So if I give you a table and the original relationships are -2, 4, the inverse relationship just ends up being switched. So it would be 4, -2. For -1, 2, it ends up switching to 2, -1. The signs stay the same, just x and y flip. 0, 0, well that one's easy, it's still 0, 0. For 1, -2, it becomes -2, 1. And for 2, -4, it ends up being -4, 2. So that's the idea of an original relation to its inverse relation. Well, what did we really do? Basically, what we did was we switched the x values and put it into the y for the inverse and the y values in for the x values. So we switched x and y values of the original to fit the inverse. Okay, so that's how we do the inverse relationships when we have a set of data points. Now let's talk about graphically. Well, since graphically is the same idea and we can pretty much grab a table, what we can do is if we have the original table, we can just switch the x and y to get the inverse table. And then we can graph both of them. So let's start with the original. And what I'm going to do is, since I know this is x to the 1 power, anything to the 1 power is line. So I'm going to just go ahead and put some x values and y values, and then I'll just substitute them in. So I'll do -2, -1, 0, 1, and 2. 2 negatives, I usually do 0 and 2 positives. And then I'm going to substitute it in. So it'd be -3 times -2. I'll just show you only one of them. Plus 6. Well, that's positive 6 plus another 6 is 12. A little bit off the chart, so I might not be graphing that one. So then we have -1. Well, -3 times -1 is 3 plus 6 is 9. Then we have 0. -3 times 0 is 0 plus 6 is 6. -3 times 1 is -3 plus 6 is 3. And -6 times 2 is -6 plus 6 is 0. So I'll plot these 4 for sure because they fall into my table, and I might just leave the -2, 12 alone. And that's what I mean. You just have to kind of think about what you can do. So I'll do -1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 0, 6. 1, 2, 3, 4, 5, 6. We have 1, 3. 1, 2, 3. And 2, 0. And then we have our original line. So this is our original. I'm just going to write original. And then they wanted us to graph the inverse as well. Well, what's nice about the inverse is if these are my points, then all the points are switched. So this is going to be 12, comma, -2, 9, comma, -1, 6, comma, 0, 3, comma, 1, and 0, comma, 2. And once again, I won't do this 12, comma, -2 because I don't have 12 spaces. So I'll start with 9, comma, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, -1. We have 6, 1, 2, 3, 4, 5, 6, 0. We have 3, 1, and we have 0, 2. And that gives us an idea of what our other line looks like. This is the inverse line. It helps having your idea as well. So this would be the inverse line. And what you'll notice is that both of these lines are actually symmetrical around the y equals x line. So if I draw the y equals x line, you'll see that it's kind of like a butterfly effect. What's happening here is also happening here because they are symmetrical. All right. So let's do this. I think we do this 2 more times. Yes, we do this 2 more times, and then that's pretty much the major concept of the day. Okay, so we have another line, and the reason I know it's a line is because it's to the power of 1. So I'm going to just create my own original. Now I am going to bold this so that you can kind of see. In the other one it was separate, but in this one it's kind of looks like it's together, but it's not. So I'm going to make up some numbers. I'll do -2 again, -1, 0, 1, and 2, and I hope that it's between a 10 by 10 screen. So -2 times -2 is 4, plus 3 is 7. -2 times -1 is 2, plus 3 is 5. -2 times 0 is 0, plus 3 is 3. -2 times 1 is -2, plus 3 is 1. -2 times 2 is -4, plus 3 is -1. So since all of that is in a 10 by 10 screen, we can plot them. So we have -2, 7. We have -1, 5. 0, 3, 1, 1, and 2, -1. And we can see our image right there. So this is the original. And now we're going to go ahead and graph its inverse as well because it says so. So we're going to switch the numbers. So 7, -2, 5, -1, 3, 0, 1, 1, and -1, 2. And I'm going to plot those 5 points as well. 7 and down 2, 5 down 1, 3, 0, 1, 1. Ooh, same spot. Okay, -1, 2. And then we're going to go ahead and draw that line. And that's the inverse. So we talked about a couple days ago how we can check to see if something is a function or not. So they are asking if the inverse is a function. And we can test by doing the vertical line test. So I'm going to run the vertical line test to see if the inverse, which is just the green one, passes. So it passed here, it passes here, it passes here, it passes here, it passes here. So I'm running the vertical line test and it looks like it does. So yes, it is a function, and explain why you think this. The inverse passes the vertical line test. Okay, so therefore it makes it a function. All right, now we have our last one, and it says graph each relation and its inverse, state if the inverse is a function. This time I'm gonna have you utilize your calculator, so that way you understand that you can also use your calculator to answer these questions. So what I'm going to do is go to y equals on my calculator. I'm going to type in x plus 1, because remember that f of x is the same thing as y. So I'm going to take out my calculator and go to y equals, and I'm going to clear the equation that I had before, and we are going to type in x squared, I just want to verify, plus 1. Okay, so x squared plus 1. And then I'm going to graph it just to see what it looks like. So that's what my image on my paper is going to look like. Then I'm going to go to second table, and I'm going to graph some things that are in a 10 by 10 screen. So I'll definitely do -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. And I can see that 0, 1 is our starting point, okay? Because everything else is symmetrical from there. So 5, 2, 1 is ultimately what I have to remember. So -2, 5. Ooh, sorry. -1. Oh, I already forgot. 2. Thank you. 0, 1, 1, 2, and 2, 5. And I just want to verify, make sure I got that right. Oh, sorry. Oh, looks good. Okay. So I'm going to plot those and get my original. So -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. And this one is my original function. Right? And then what we're going to do is now I'm going to switch my colors, and we're going to do the inverse points. So the inverse point would be 5, -2, 2, -1. 1, 0, 2, 1, and 5, 2. All of these points, x's and y's switched. And now we're going to plot that 5, -2, 2, -1, 1, 0, 2, up 1, and 5 up 2. And here's what our inverse looks like. And the question is, once again, is the inverse a function? I'm going to run the vertical line test on just the inverse. And it failed because that one vertical line touched 2 points on that inverse function. So it is not a function. Explain why. My reasoning would be very clear, and the reason is the inverse did not pass the vertical line test. All right, everybody. Well, that's all I have for today. So I hope that was the idea of inverse isn't so complicated, that it's literally the switching of the x values from the original and becoming y values of the inverse, and the y values of the original becoming the x values of the inverse. Okay? So I hope that was helpful. Looking forward to seeing you in class. If you have any questions on these notes, just go ahead and write them down on your paper so we can address it in class. Have a great day.